Hello guys, welcome to another discussion. So in today's discussion we are going to look at the chain rule. So obviously we are going to look at how do we apply the chain rule and when do we use the chain rule. So let us look at what we have on the board here. So if a function, some function of y which is equals to f, in which f also contains another function u of x, and then finding the derivative or differentiating y, we are going to say it's dy du multiplied with the du dx. So first of all, we're going to figure out what is our dy du and what is our du dx. So before we do anything, I'm going to bring you back to this function here. So this is some function f of x in which it contains u, which is another function of x inside it. So to make this one look simple, or what we have here, it is as good as the first example here. We have y which is equals to some function. So this is some function raised to power 5, of course, which is a function of x, and then inside it we have another function x plus 7, which is another function of x. So we can therefore, so for this one we can therefore say let u then u becomes what is inside here, which is x plus 7, so that that other function, or so that our y looks something like u to power 5. So we know to say that u, it is some function of x, which is this one here. So this is what we have. This is the interpretation now. So now, finding our dy dx, first of all we need to find our dy du and also du dx. So we'll start with the dy du. What is dy du? It's based on what we have here. So let us differentiate this one with respect to u like that. So this then, since because of the power, we are going to use the power rule where we drop down the power and we say that, so this is 5 times u to the power of 4, and then du dx. Du dx is based on what we have here, which then gives us 1 like that. Now dy dx will then be equal to dy du multiplied with the du dx, so that if we are to cancel out this and that, it gives us back what we have here. So let us substitute what we have there and see what we end up having. So from there, what is our dy du? Dy du, it is 5 u to the power of 4 like that. And then since these two are multiplying, so we are going to say du dx, which is just a 1. So it's just this what we have multiplied by 1 like that. So now this is then your final solution. But remember, you define du to some function here. So we are going to substitute u for what we have there. So then therefore we can say dy dx is equals to 5 multiplied by u. So our u, it is x plus 7 to the power of 4. So we're going to write our 4 up there. So then this then becomes our final solution for this problem based on the chain rule. So we can then look at another similar example. Okay, so now we have another example again. This example will still be based on the chain rule. So we have a function y which is equals to cos, and then we have another function within a function which is x squared plus 3. So this is 3 like that. So solving for this problem, we then let u be equal to this, so that our u looks something like cos, our y looks something like cos u like that. And then you're going to first of all work out for dy du, and later on we're going to solve for du dx. So dy du is obviously based on y and u here. So differentiating this one, you can say this then becomes negative sine of u like that, and then du dx is based on u and the x there, so that we have 2x like that. Then this implies that dy dx, which is equals to dy du multiplied by du dx, this will then be equal to, what is our dy du dx? Dy du is negative sine of u multiplied by 2x like that. So then you just need to simplify this one. This one will then become negative 2x then sine. Then where there's a u here, we have defined the u to be x squared plus 3. So we're going to write our x squared plus 3 like that. So this then becomes your final solution for differentiating this function here, which is negative 2x multiplied by sine of x squared plus 3. So here is another example that will be solved based on the chain rule. So the chain rule, obviously, we are saying it's a function within a function. So let us look at what we have here. So we have y, which is equals to e to the power of 2x plus 1. How do we solve this one based on the chain rule? So the first step, we need to define our u. How do we define our u, or which is our u? So our u will then be equal to 2x plus 1, so that our original function looks something like e to the power of u like that. And then you first of all solve for dy du. How do we find dy du? Of course, dy du is from this part here. So how do we sort out for dy du? Differentiating this one with respect to u, we end up with the e to the power of u, and then differentiating this will be du dx. So solving for du dx, you see u and the x, of which we end up having just a constant 2 there. And then this implies that dy dx, which is given by dy du multiplied by du dx, is equal to what is our dy du? Dy du is e to the power of u multiplied by du dx, which is just a constant 2 like this. So now the next step is that we have our 2 and our e there, but this u has been defined as 2x plus 1, so we'll then write it as 2x plus 1. So this is how you solve problems similar to this based or using the chain rule.